What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we are starting a brand new interview question pattern all about binary trees, specifically level order traversal. Now, I've made a few videos in the past about binary trees and all the various kinds of traversals that you can use to traverse those trees. I highly suggest you check those out before this video. If not, though, that's all right. We're going to go over some basics today in this introductory, relatively easy problem video. And yeah, let's get started. Okay, binary trees. What are they? Binary trees are data structures in which a node is linked to two successor nodes. So classic, you got your root node, and then it has two children, and then those nodes can have each two children, etc. Often we are asked to traverse the tree, meaning looking at the nodes making up the tree in a specific order, depending on the type of traversal. For this interview pattern, we will be exploring breadth first traversal, aka level order traversal. This is when the traversal order is level by level. So if that root node is the first level, and then its children are the second level, and then those children's children are the third level, etc. To do this, we will use the queue data structure. If you don't remember what a queue is, it is first in, first out, just like when you're standing in line at the grocery store. And yeah, I think that's just about covers our introduction for this interview pattern. So this is just going to be a picture of what a binary tree might look like. So you can see we have our root node, which is 1. It has 2 children, 2 and 3, and then 2 has 2 children, 4 and 5. 3 has 2 children, 6 and 7. And each level will be, the root node is the first level. Its children is the second level, so that's 2 and 3. And then finally, our third level, which is 2 and 3's children, 4, 5, 6, and 7. So in level order traversal, we will be traversing this. We will traverse 1, and then we will traverse the entire level 2, which is 2 and 3, before we get to level 3, which will contain the nodes 4, 5, 6, and 7. So that's level order traversal. This is the alternative to traversing this in a possibly depth first search kind of way, which would go 1 to 4, maybe then 5, etc., where you're kind of going down an entire branch of the tree before you go to the nodes that are all in the same level. So that's the story. We're doing level order traversal for this interview pattern. And yeah, so what's this week's problem? Given a binary tree, populate an array to represent its level by level traversal. You should populate the values of all nodes of each level from left to right in separate subarrays. So what does that mean? Let's take a look at our example. So we have our same tree from the slide before, and essentially we want to return an array of arrays, each subarray representing a level of the tree. So level 1 will have 1 in it, level 2 will have 2 and 3, and level 3 will have 4, 5, 6, and 7. So what's our approach here? We're first going to initialize a result array to keep track of all of the level subarrays. We're also going to initialize a queue to keep track of the nodes that we're traversing. Remember, first in, first out, that's our queue data structure, and that's important, and a real key here for this pattern is that generally you'll be using a queue to keep track of your nodes. We're going to push our root node onto the queue to start us off. And while there are nodes in the queue, we're going to initialize a current level subarray. So I think I'm going to walk through the code with a debugger once we get to that step, but you'll see that when you're in the while loop, each time the while loop iterates, we're going to end up with certain nodes in our queue. And each time we go through the while loop will represent the current level that we're at. And again, you might not get that until we start to code this out, but you'll see when we code it out how that works. So we're going to initialize the current level subarray with each iteration of the while loop. We're going to capture the level size, which will be queue.length. So because every iteration of the while loop will represent traversing one level, that means that the queue at that point, all of the nodes in that queue will be representing a level. So we'll know our level size based on q.length. Then for level size, so we'll have a for loop and we'll go through the level size amount of times. We're going to collect all the current levels children and push them to the queue. Then finally, we're going to push current level subarray into the results array, and we're going to repeat this until there are no nodes left in the queue. So again, this is actually a problem where I think the pseudocode is a little confusing without the actual code. So keep this in mind, but I think it will become much clearer once we actually code this out. But let's look at a visualization of what our plans are. So here is our tree. This is the same tree that we've seen in the previous slides. We have our queue, we have our current level subarray, and we're going to start by pushing our root node onto the queue. So there we go. We have our one that we've pushed onto our queue. And now we're going to start iterating in our while loop here. So we can capture our level size by looking at the q.length. So q.length here is 1. And basically, we're going to initialize a for loop, and one time we are going to push all of a node's children. So that will be look at its dot left and look at its dot right. So that's why even though the level size is 1, we will be capturing both of its children because one iteration of our for loop is going to capture the left child and the right child. So we shift our 1 out of the queue. We shift it because we want to take from the beginning of the queue, first in, first out, and we push it to our current level subarray. Now our level size is 1, so we're going to start looking at its children, 1's children. So we go to 2, we push it to the queue. We go to 3, we push it to the queue. Okay, so at this point, we've finished our for loop, because remember we did a for loop for the size of 1, and we're going to go back to the top of our while loop. And we have a queue length of 2, so our level size is now 2, and we're going to shift from our queue. So now for our for loop is going to be going 2 times because our level size was 2, and for each iteration of the for loop, we're going to gather the left and the right, the left and the right. So just, stay with me. So we're looking at 2 now. So this is our first iteration of our for loop. We push 2 to our current level subarray, and we start looking at its children. So 2 has a left and a right, 4 and 5, and we are going to push both of those. We're going to push both of those onto our queue like so. Now, remember, we're still in our while loop iteration. So despite the fact that now we have 3 things in our queue, we are not going to reinitialize level size until we are fully complete with our for loop that was nested inside our while loop, which we are not done yet. We've only done 1 of our 2 iterations of our for loop, representing 2 and its children. So now we are going to shift again from our queue, which is going to be 3. We're going to push that to the current level, and we are going to finish our iteration of our for loop. We're going to take its left child, 6, add it to the queue. We're going to take its right child, 7, and add it to the queue. Now at this point, we have finished our iteration of our for loop for our second level, which was of size 2, and we are going to push 2, 3 into our resulting array, and we are going to start again. Our queue length is 4, so our next level size is 4. And of course, none of those actually have children. So we will just shift from the queue and start adding to our new current level array. So we have 4, then we have 5, then we have 6, and finally we have 7. And we push that current level into the result array, and we have our level 3 represented. So that's the approach. Again, I think it will actually be the clearest when we code this out. But after we code this out, I highly suggest returning back to these approach slides and rewatching just so you are actually positive that you're following along exactly how this is working. And I think the things to really watch out for here is when we're going through the while loop and when we're going through the for loop. But again, you'll see that in the code. So let's code this out. Okay, so I am in Visual Studio Code, and I think the first thing we have to do is define our tree node class, which will be the class representing each node in the tree. So I'll start by defining a class of tree node, and we'll add a constructor, and the constructor will get a value, and we will set this dot val equal to the val passed in. The other thing we'll want to do is initialize the tree node's left and right children, because every tree node has the possibility of having 2 children. So we can say this dot left equals null and this dot right equals null. And that is the whole tree node class. So very easy here. And then finally, we'll want to define some test cases before we actually jump into writing this traversal code. So let's say const root is a new tree node of 1, and then we can say the root dot left is a new tree node of 2. We can say the root dot right is a new tree node of 3, and then we can do our root dot left equals new tree node. I think that should be a 4. This is going to be our left dot right will be 5. Root dot right dot left is going to be a new tree node 6. And finally, our root dot right will be a new tree node of 7. So let's see here. So let's say we want to do our problem. We can call it maybe level order traverse, and it will get passed in the root. And we already know we're going to want to return in array, so let's initialize that. This is also not how you define a function. Hang on. There we go. And then we can return our result right like so. And let's do a console log level order traverse and pass in our root and call it a day. No? Okay. Okay, so what did we want to do here for our level order traverse? We want to define a queue. This is going to keep track of the nodes that we have to traverse, right? So let's do that. Queue equals an array, and immediately we are going to push our root node onto our queue to start us off. And then we initialize a while loop. While there's a queue.length, meaning the length is greater than 0, we are going to be doing certain things. So here what we want to do is we want to capture the level size, which will be queue.length. We want to loop through level size and add children to queue. And I think that's all we want to do. And then at the end, we want to, I would say the only other thing we want to do here is capture the level size, initialize current level subarray, right? Loop through the level size, add children to queue. And the other thing we will want to do is add nodes to current level subarray, and then loop through the level size, adding children to queue, and finally push current level subarray to the result array. And that's basically all we have to do here. So let's actually code this out. So we can say that the const level size is queue.length. And what's the next thing we have to do? Initialize a current level array. So current level is going to be an empty array. And then we will want to start our for loop here. So let's move this up. And let's say for let I equals 0, I is less than current level. No, current, we want I is less than level size, I plus plus. Okay, so this is where we're going to actually start to look at what's in our queue, push things to our current level, and also push children to our, parent overarching big queue that we have up here. So first we're going to shift from our queue so we get our current node. So let's say const current node equal queue dot shift. So that will take off from the beginning of our array. And essentially we're going to if our current node has a left, we are going to push our current node dot left into the queue. And then if the current node has a right, we're going to do the same thing. Queue dot push current node dot right. So that takes care of, for every iteration of our for loop, getting all of our current node's children and pushing them to the queue. But we also want to be keeping track of what's in our current level. So let's do that up here. We can say current level dot push current node, and I think we can take its value because we only want to see the values of our nodes in our ultimate result array. And I think that might be it. So at the end of this for loop, so let's move this label up here. We are finally going to just result.push our current level. And that's our whole algorithm, I believe. So essentially, I think the things that you need to know, again, are that each iteration of our while loop is going to represent a level. And like I said, I'm going to walk through this with a debugger to really show you exactly what's happening. First, let's make sure we get what we wanted. So let's say node code. And we have our result array, and we have subarrays representing each level. So we have our 1 in a subarray, we have 2 and 3 in a subarray, and then we have 4, 5, 6, and 7 in a subarray, finally, representing level 3. So let's walk through this with a debugger and just watch how this actually is working. So I'm going to add a breakpoint here, and we are going to run and debug this with node.js. And I'm going to add some things to our watch because there are certain things that we want to kind of watch the whole time. So let's watch our queue. Let's watch our level size. Let's watch our current level. What else should we watch? I think that should be good. We could watch our results too. Okay, and I'm just going to step over and basically watch how these things change as we step over through these through the function. So we first have our tree node with the value 1. I'm going to make this a little bigger in our queue. And that's where we start off our while loop. So our level size here is going to be 1. So we have a level size of 1 because that's the queue.length, and we start to iterate in our for loop. So we're going to go through this one time. We're going to shift off of the queue. So we're going to grab that 1. We're going to push it onto our current level. So now current level will have a 1 in it. And we're going to push its left children and its right children. So now in our queue, we have a 2 and a 3, and we are finished with the iteration of our for loop, right? So we're going to push our current level array, which is just a 1, onto our result array, and we are going to continue iterating through our while loop. So here we have a queue size of 2, because we have 2 nodes in it, 2 and 3. And we are going to continue to step over. So we have our level size of 2, we have our newly initialized current level array, and we are going to begin to add children to back to our queue. And we're going to go through this for loop 2 times for our level size of 2. So our current node is 2. I guess I'm not tracking that, but I can add that here. So our current node is 2. We're left with a 3 in our queue. We push our 2 onto our current level subarray. There it is right here. We push its left children. We push its right children. Now, this is the interesting piece here. So we're kind of midway between our while loop iteration and our for loop iteration. And at this point, we have a 3, 4, and 5 on our queue. But the reason why we don't reinitialize our current level size to 3, which would be a mistake because 3 is on level 2 and 4 and 5 are on level 3, is because we have not exhausted our for loop yet. we need to go through our for loop one more time because our level size had been 2 and continue pushing children onto the queue. So our new current node will be 3, which we will shift off of our queue. And we will push that to our current level subarray, and we will grab its children and push it onto the queue. So there we pushed 6, and there we pushed 7. And finally, we are done with our for loop. So we push our current level, which is 2 and 3, onto our results array, which now has one subarray, which is 1, and another subarray for level 2, which is 2 and 3. And we will go through the while loop one more time. We have a queue.length. Our level size is now 4. Our current level is empty. And for each of these, we are going to push its left and right children, which obviously these don't have any left and right children. So we are just going to skip over that and continue adding from the queue onto our current level array. So we have our 4, we have our 5, we have our 6, there we go, we have our 6, and finally we have our 7. And then we've exhausted our for loop because we went over level size was 4. We've gone over our for loop 4 times. So we get to our final result.push, and there's nothing left in our queue because none of those nodes had any children. So we push our current level to our result array, and queue.length is 0. So we are done. We return our result, which is this array of subarrays, each representing the levels. So I hope that was clear to everybody. I think it's really important to kind of understand why we can do this and where we are capturing our levels in our while loop compared to our for loop. So go over this a few times, pen and paper, debug it, go back to those approach slides. But, otherwise it's a relatively straightforward algorithm, I think, when you actually see it in code. And next week we'll raise the stakes a little bit and do something a little harder. All right, that's all I got for you today, everybody. Join us next time. We'll be doing a slightly harder breadth first search level order traversal problem with a binary tree. And again, look back at our previous videos on this channel all about binary trees and the traversals if you were having trouble following this problem. I think the other videos we've done in the past have really been more about the basics of these algorithms. And if you're having any trouble at all, I really suggest you go back and watch those videos first. And if not, I'll see you all here next time. Thanks. Bye.